All right, let's review areas between curves. As always, first, look at the quote by Fyodor Rozak. Okay, please read it. As the previous video, this is knowledge you really need for your Calculus 2. So be aware, do not skip it. All right. Remember, as always, enter learning mode. Use your metacognition to adjust your mindset. Move away any distractions. Please pause the video, take 3 deep breaths from your belly, inhale in a count of 4, exhale in a count of 6. After you do that, you should feel relaxed, open, positive, focused. And feel free to add any word that relates to your feelings. If at any point you notice your mind wandering off while watching the video, it's okay. Notice it. Don't make any judgments. Gently go back to the place you were understanding and continue. Okay, let's see. Areas between curves. So we need to you want to find the area between two curves. We can work this with respect to the x-axis and with respect to the y-axis. So every time you want to find the area between, in this case, f of x and g of x, to those two curves, what you're going to do is you're going to take the integral of the top function, which is this area between the top function and the x-axis, and you're going to subtract this little piece. So you take the big one minus the small one, what you get is the shaded area. Very intuitive and logic. And if you're doing it with respect to the y-axis, and be aware here functions have to be functions of y, then you're going to take the right function minus, the area to the left of the right function minus the area to the left of the left function. So it is here, so you take the big area from the y-axis to the furthest function, and then the area from the y-axis to the closest function, and subtract. That's all we need to know. Let's see some special cases that are worth working. It's always, when we're going about x, it's always the top function minus the bottom function. But things could happen. Like in this first example, right there, you see you have to split your integral here because the top function is changing. On this side, on this piece, the top function is the sine, whereas the bottom function is g of x. Okay? As soon as you go over this point, then the top function is g of x and the bottom function is the sine. So if you were to find the area between this curve and this curve, from pi over 4 to 5 pi over 4, you would have to split it here. And in the first integral, from pi over 4 to the middle here, 5 pi over 8, I believe, take this top function minus this bottom function. And from here to here, you have to take this top function minus this bottom function. You have to split it up. In this example, same thing happens. If you're going about the x-axis, then you have to split it here. And then the root x would be the top function, and this would be the bottom function. But it's just the x-axis, so it's just the area below the square root of x, okay? And then you would have to take this function, g of x, and take the integral. So you would have this area plus the previous area. That's how you have to do it, but you have to split it here. Whereas if you're doing this with respect to the y-axis, then the right function is always the same and the left function is always the same. You don't have to split anything. You would do the integral from 0 to 1 of the right function minus the left function. Okay, and as you can see, it also happens in this example. If you go about the x-axis, the top function here is the purple one, whereas here is the blue one, so you have to split it up. Whereas if you do it about the y-axis, then you would have to do just the integral of the blue one minus the integral of the purple one. Okay, so if the curves intersect, you get these pieces of area, okay? And every point of intersection could mean that the top and the bottom functions are changing. If there's no intersection, like maybe if you stop at a point here, there's no intersection there, nor to the left, nor to the right. So on all this interval, because there's no intersection between the two functions, we know that's always the top function minus the bottom function, and the top function is going to remain always the same one. Well, as well as the bottom function. Alrighty. So here you have more examples. Probably the problem tells you to go from A to B, and it doesn't matter if they intersect or not on the outside. Just you would have to see if they intersect between A and B. By if you have the graph like this one, you would know it does not intersect. If you do not have the graph, you would have to intersect the two functions and find that the 2 points of intersection are outside the area or the interval where we want to find the area between the two functions. And recall that every time you have an interval being coming out negative, is not that you have negative area, right? Is that the function is lying below the x-axis. So that area is happening below the x-axis, okay? If you want to find the area here, you would have to go from 0 to 1, and that will bring you a negative value, right? But if you're doing the top function minus the bottom function, it works. So you see, it's always the top minus the bottom. It doesn't matter if the function is above or below the x-axis, because the top function here is 0, and that would be 0 minus that function. You see? And because you're doing the negative of that function, of this function, the area is coming out negative times that negative, it's going to be positive. So that's why it's always the top minus the bottom. It doesn't matter where they are. And well, here's another example, just like the previous one. Here it would be the right function minus the left function. And if you do it about the x-axis, you would have to split it here. And because this is not a function, you would have to do other considerations to get the lower part, like for example, symmetry. So let's do the first example. We're going to find the area between these two curves about the x-axis. Okay. Not difficult at all. You just have to recognize what's on the top, what's on the bottom, and do the integral, the top minus the bottom. So in this graph, the shaded area is going from 0 to 2. So the first thing is the limits of integrations. To establish that area, the shaded area, would go from 0 to 2 of the top function, and the top function is x plus 1. Okay, so that would be this area here, all that area, and that's x plus 1. That's the top function, minus now the bottom function. It's this one right here, x e to the negative x squared. X e to the negative x squared dx. Because if you're going about the x-axis, everything is in terms of x. Okay. And well, maybe this is good to refresh again your substitution. Kind of easy to do here. Let's split the integral because the left one is really easy. X plus 1 dx. And the next one, we need to do a little u substitution. So the left-hand side is just x squared over 2 plus x, and evaluate from 0 to 2. On the right-hand side, we need to make a little u substitution. U equals, you could use x squared or negative x squared. Let's use x squared. Then du equals 2x dx, and dx equals du over 2x. Okay, so I'm going to keep the blue so you see it where I'm using the u substitution. That would be x e to the negative u, and then dx is du over 2x. Okay, the x is cancelled out. That's what we know. The only thing left to do here is find the limits of integrations due to the change. So I'm going to do it right here. So for x equals, the lower limit is 0, right? So for x equals to 0, u is 0 squared, which is just 0. So the lower limit is 0. And for the upper limit, which is 2, x equals 2, then u equals 2 squared, which is 4. So the upper limit is 4. Okay? And we get, let's do the evaluation at the end. Let me go back to the gray one. X squared over 2 plus x from 0 to 2 minus the integral of e to the negative u du, and then 1/2 in the front. Okay, let me start evaluating. Let's plug in the 2, so that's 2 squared over 2 plus 2 minus 0 minus 1/2, and now let's take the integral. What's the integral of e to the negative u? That's e to the negative u, but remember, because this is a constant, -1 multiplying the u, you divide by -1. That's going to change the sign, so that's negative u to negative u. Oh, I didn't write the limits, 0 to 4, from 0 to 4. And let's take care of the signs here. So this is 2 squared over 2, which is 2, plus 2, this is a 4, plus, I'm going to put the sign out to the substitution easier, e to the negative u from 0 to 4. So that's 4 plus 1/2 e to the negative 4 minus e to the 0th power, which is 4 plus 1/2, and here we have e to the negative 4, and e to the 0th power is 1. So that's 4 plus 1/2 e to the negative 4th power minus 1/2. 4 minus 1/2 is 7/2, and then plus 1/2 e to the negative 4, or you can write it if you want to. All depends what the lab is going to ask you to do. You can write it like that also. Okay, we're done. On the next example, we're going to go about the y-axis now. Okay, so again, it's the function to the right minus the function to the left. Is this function in blue minus this function in red from this point? So you need to find the limits of integration, on the y-axis. So from here, from -1 to 3, right? Of this function minus this function. Just keep in mind something very important here is that if you're working about the y-axis, everything has to be a function of y, okay? And it is given to you like that. But if it's not given, you have to solve for x. So you already have it solved for x. So this would be, I don't know, f of y, and this you could call, I don't know, g of y. So you're gonna do f of y minus g of y. Okay. If you didn't have the graph, because the graph is telling you for which y's these two curves are intersecting. If you didn't have the graph, for example, you would have to take the two equations, like -y squared plus 10, and equal them to find for each y's the curves have the curves intersect. Okay, so let's equal them and do a little algebra to find the y. Y squared minus 4y plus 4. And then let's move everything to the right. Easier. 4y. And then subtract 10 on both sides. That's -6, right? And then factor 2y, y, 6 and 1 is going to give me a 4. I need the 6 to be negative and the 2 to be positive to get -4. Okay, all right, like that. So y equals 3 or y equals -1. So if you were not given the graph, if you don't have this at all, you'll know that your y's would go from -1 to 3, okay? Then you would have to see which is on the right and which is on the left by plugging in a number, okay? So because there's not going to be a change in who's to the right and who's to the left between -1 and 3, because those are points of intersection, you just plug in, let's say, if you plug in 0, you're going to find that if you plug 0 here, you get 10. And if you plug in 0 here, you get 4. So you will know that the blue one is on the right and the left one is on the red. And and the red one is on the left. So that is if you're not given the graph. Okay, but here we have the graph. So you're going to take the integral from -1 to 3. And now the right function, which is the blue one, minus the red function. And we put it red, or kind of reddish. Y minus 2 squared. And dy. About y, everything has to be in terms of y. Okay. And let's just integrate this. It's going to take a little long. Please try to do, so again, I did go all the way, but try to do things before I do it. Try to work it out, pause the video, do it, and then turn on the video for insights to check your work, okay? So let's do the integral here. And well, this integral is really polynomials, so it's not a big deal. It's -y squared plus 10 minus y squared plus 4y minus 4, right? I'm just checking not to make a mistake. -y squared plus 4, okay, dy. Now combine, work vertically here. Combine -2y squared plus 4y plus 6 dy. Now integrate -2y cubed over 3 plus 4y squared over 2 plus 6x. Everything from -1 to 3. Let me simplify first. That's -2/3. I'm going to keep the 2/3 in the front. Y cubed plus 2y squared. Oh, I'm sorry. That's because I'm used to x. If I'm integrating 6, if with respect to y, this is a y, not an x. Sorry. 6y, everything from -1 to 3. And then plug everything in. 2/3, 3 cubed plus 2, 3 squared plus 6 times 3 minus, keep that negative sign there, -1 cubed plus 2 times -1 squared plus 6 times -1. Okay? And I'm not going to do all the fractions and stuff. You get, what, 64 over 3. Okay? And we're done. That, I hope, helps you refresh areas between curves. Alrighty. See you in the next one.